today we are going to be going over a Mocha Pro and Nuke workflow. I'll be hosting, and Martin Brennand, our amazing product manager, is going to be going over the Mocha Pro and Nuke workflow. So we do these webinars about once a month, and so far we've been getting a lot of really good feedback from you guys. Please keep it up. As long as we have interest for these, we will keep doing them. A lot of you guys asked for a Nuke workflow, so here it is. And without further ado, I'm going to let Martin Brennand take it away and show you guys how to use Mocha Pro with Nuke to increase your productivity with planar tracking.
Okay, hello and welcome. So as Mary said, I am Martin, the product manager of Imagineer Systems, and I'm coming to you from the lofty and magical shores of Melbourne in Australia. So today we're going to be covering the introduction to Mocha and Nuke workflow. I'm not going to go node crazy, but I am going to cover in depth the more standard methods of using data in Mocha and in Nuke. So it's going to be pretty fast-paced as there's a lot to cover, but definitely let us know if you want to see extended tutorials on particular sections. For example, I'm going to briefly cover the 3D camera solver, but we do have a nice extended tutorial on Nuke and Mocha specifically for 3D solving, so you might want to check that out as well. Now, there's not just one way to do things, however, so if you've got some great Nuke techniques you want to share, definitely let us know in the feedback afterwards. Okay, so let's just go to the breakdown. So I'm going to do a quick planar tracking crash course designed purely to get people less familiar with Mocha up to speed, but this will be a crash course specifically. So if you're unfamiliar with Mocha's tracking, I recommend checking out our tutorials, but this will get you an up to speed to know how the tracking works and how to get going with it. And we've got plenty of tutorials online to cover many, many different aspects of Mocha tracking. I'm then going to go through how to get that tracking data into Nuke. This part will be a little bit more technical and less arty, but I'm going to show you the various options, and then that will lead into merging some inserts using some corner pin examples, and we'll go over a little bit of rendering inserts and how to sort of apply distortion to those inserts and alphas and all that kind of fun stuff. After this, we're going to jump into tracking for Roto and camera solving. This is going to be sort of a combined project where we're going to go through the Roto node, we'll talk a little bit about the Roto Paint node and matte rendering, and all combine that with a camera solve for a card replacement in a set extension. And then finally we'll go through using lens distortion in Mocha and exporting those to STMap nodes. So now some people have asked, why use Mocha when we've got this perfectly good tracker inside Nuke? Now the main reasons are, one, planar tracking is very different to other available feature trackers and even other planar trackers. It handles very difficult situations like focal and motion blur, obstructions, and minimal detail very, very well. It's built from the ground up to be a tracker first. It's the layering system, the Roto, and all the modules are driven around the planar tracking concept. You can also track as much as you like in one go, layer upon layer. So this is very, very handy when you want to track obstructions through a shot and at the same time track things that they are actually obstructing. So you can then link everything up to cut down time on other layers such as Roto. And it also complements Nuke very well. We export to the standard tracking and Roto formats as a simple copy-paste, and that makes it fast to switch. And we've also got a lot of other formats supported. So we've worked with the Foundry on a number of occasions to make sure artists are getting easy integration with minimal data overhead. So it's a good alternative for getting some extra tools under your belt if you only have specifically Nuke rather than Nuke X, and you're still in need of the additional tracking tools or a 3D camera solver. If you do have Nuke X, you also have an alternative tracking solution because that's very useful, especially when you're stuck on a hard shot. And of course we've got all the other modules such as the remove tool, which is great for cleaning up shots really quickly. So today I'm going to be using Mocha Pro 3.2.0. This just came out last week. So those on version 3, you can update to version 3.2 for free. Anyone less than Mocha Pro 3, I recommend upgrading. So this has new support for Unicode. The Unicode means that anyone using non-Latin file names or just general layer names means that that will be properly supported in the code base now. It's really good for international artists who are using Chinese, Japanese, Chinese, German, all those kind of things. So it makes it a lot easier to have a more streamlined file workflow in your native language. We've also got some good Mountain Lion support in there to deal with license issues in Mountain Lion, and some great new 3D null features to just help present more accuracy with those nulls and show what those nulls are coming from inside Mocha. Before it was a little bit of smoke and mirrors. And there's plenty of other fixes and enhancements. So let's get on with it. So over here in Mocha, I'm going to start by loading a project. So the new project window is, the most important part of the process, purely from the ability to set up your parameters. You must get this correct early on so that when you bring it over to Nuke, it all syncs up nicely. So in this case, I've got a frame range of 0 to 99, and I know my frame rate's 24, so I'm going to keep it at that, and my pixel aspect ratio. The main ones you really need to get right are these two, because if you export tracking or roto data out to Nuke and the frame rate or the aspect ratio don't match up, you're going to get a lot of bad syncing inside Nuke. Also, if we switch over to the Advanced tab in the new project window, we've got the frame offset. Now, I'm going to set this one to 0 because I know in this case my frame offsets are 0 in Nuke, but you want to be able to set this to what your general frame offset is going to be. A lot of people work with the 1001 frame offset, so you might want to set that there, or whatever you need to work with. So I'm going to click OK. And I don't want to overwrite that one, so I'm going to put new_new, and we'll overwrite that one. Okay, so here we have a nice train coming through Piccadilly Station, and I'm going to go through some quick tracking concepts here. So when you're tracking a shot like this, I'm going to specifically replace this sign up here. You want to be able to track from the biggest detail down to the smallest detail. So I'm going to find a nice frame up here somewhere. So about here will probably do. And I'm going to draw shapes to capture the planar information on the front of the tube train here. So up here we have our drawing tools. We've got X-splines and Bezier splines. Bezier splines everyone will be used to. It's just the standard pen tool. I'm going to use X-splines because they're much more nice to draw with. So I'm going to just draw around the detail here. Now you'll notice I'm avoiding the windows. The reason I'm avoiding windows is for two reasons. There's reflections in the glass, and we want to avoid reflections because Mocha sees those as additional planes. And there's also a plane behind the window here that is slightly on a different plane to this foreground plane. So I'm just trying to avoid that. You'll see that I'm not completely avoiding it if I just turn on my matte for a sec. You can see I'm going outside the edge of this here, and I'm going inside the edge of the window. This is just to tell Mocha I've got an edge here, and look for the contrast difference between this foreground element and any background elements. So once we've got our matte shape, we can set up our parameters. So I'm going to leave my input channel to luminance. This just means convert the footage to black and white and get some luminance data to track with. If you don't have a lot of good data in your shot, it's best to switch to auto channel, because auto channel will try and find the best contrast in either the RG or B channels. So in this case, luminance is pretty good, and most of the time, I would say 90% of the time, luminance is fine. Now, minimum percentage of pixels is very important. You want to set that to about 90. 90 is a good value because it's using most of the data, but it's still going to be reasonably fast. The percentage of pixels works on an accuracy basis, so the less pixels you've got, the less accurate it's going to be, the slower it's going to be, but obviously you'll get accuracy. So there's a trade-off one way or the other. The smoothing level, you can normally keep it 0 because Mocha is pretty robust with its tracking, but the smoothing level basically does a pre-blur on the image. So like if you're working with really badly, heavily grainy footage or a really stormy, rainy scene, sometimes smoothing level helps, but in all the time I've ever used Mocha, I've never had to use this. So if you ever have to use it, let us know because we'd love to see the footage. So I'm going to now track this, and I'm going to turn on perspective because there's some perspective in this shot, and I'll leave all the other settings just the way they are.
So Martin,
before I start, yeah?
When you're tracking, what exactly is Mocha looking for inside of that shape?
So in the entire matte area, it's looking for every single pixel in this texture. So it's treating this whole matte shape as a texture, almost like you've grabbed this shape underneath my matte and you've just plastered it straight onto like a 3D plane. So it's going to try and follow how the texture underneath the mat is moving through that shot. So we can turn on my surface. Now the surface is what you will end up exporting out to Nuke. It's a corner pin surface, but you can also use it to triangulate a central transform point if you need to. It's also really good though for visualizing your track. So I'm going to just move this down and line it up about with the perspective of this train. And I'm going to turn on my grid just so we can see a little bit better. The grid is just a helper tool. It doesn't have any other function other than a nice visual tool. So you can see how that little subtle change will move the grid around. And then we can start tracking. So I'm going to start tracking forwards. And you'll see how that tracks forwards quite easily, capturing onto that texture. Now I'm not going to track the entire shot. I'm going to go to a pre-baked shot because watching me do a track will probably be rather dull. So I'm just going to show you this little bit just to demonstrate how you can manipulate this surface after you've done the track. Okay, so we've just tracked that small section. So once we've done this track, we can still move around this surface. It's completely separate from the tracking data, like a child of the object. So we can move it around, and then it will still be relative to that tracking data. So this is very, very important because it's really useful for adjusting tracking when you get it into Nuke. So I'm going to just load up a finished file of that.
So what you're saying about the surface tool is those would be your final points as a corner pin, but also your final tracking data location.
Correct, yeah. So this tracking data is representative of all the what you would export out. So where you position your export is how it will be represented when you paste it into Nuke. The actual tracking data itself is one big sort of majestic invisible plane that can be anywhere out here. So for example, I could just undo that and move my surface out here somewhere, and it would still be on the same plane as the front of this train. It just wouldn't be represented in where we want it to be. So it's just a nice little child tool to be able to export out where we actually want the physical data. So I'm going to export this data out now. We can preview this insert by just inserting a simple logo, and coincidentally that's what I'm going to be using inside Nuke, but we're going to just export this data out. So I'm going to turn this logo off because I don't need to see it in this shot, and we'll export out some tracking data. Now the two main default tracking data for Nuke is Nuke corner pin, which is the standard corner pin node, and Nuke ASCII, and this is the 4 files that you can load into 4 tracker points in pretty much most versions of Nuke. I'm going to be using Nuke 7 today, but it's still a valid way to import data. You can also copy straight for the corners of your corner pin, and I'll show you how that all works in Nuke. So I'm just going to copy that to the clipboard, and we'll switch over to Nuke. So I'm just going to load up Nuke here.
And this is literally a copy-paste?
That's correct. So I'm going to read in a node, like so. So there's my train. And let's just fill the screen with that. So we want to put that same insert in, so I'm just going to come right to the end of the frame here so we can see it nice and big in the shot. And I'm going to read in my insert. So let's bring in I'm blind, there we go. So when we bring in a insert, the first thing we want to do is just merge it over the top of the original footage. So I'm just going to hold down Shift with this selected and Shift select the footage, and then I'm just going to press the M key to merge it over the top. So right now it's big and ugly in the shot. And so we want to be able to paste the corner pin data between the read node and the merge node. So I'll just switch over to my mouse. And I'm just going to, as Mary said, just press Control or Command V, depending on what system you're on. I'm on a Mac, so I'm using Command, Control, and Paste. And then that pastes the corner pin data straight into the node graph. And we can double-click that, and we can see our animated data as it represented inside Mocha. Now there's one more way, well, there's actually 3 or 4 more ways, but there's one major more way to get the data in. It's not through the corner pin, it's actually through the tracker. Now, the tracker node is a little bit different in that it deals specifically with its own tracking, but you can import tracking data from Mocha to help use it for transforms, match moves, and stabilizers. So if I just move my corner pin out of there, we can do this in a couple of ways. We can either convert our corner pin data to a tracker node via a script, and I've got a script up here from Nukepedia called corner pin to tracker. This is from a guy called Blue Faces on Nukepedia, and it converts immediately our corner pin data straight to a tracker node. So I'll just click on that. And there's our corner pin, our tracker. So the only downside to this particular script is that it can only load the old tracker from before version 7. It's still useful because you get all the same transform information and you get to set a reference frame and set the type of transform, but it doesn't have all the new funky features that the Nuke 7 tracker has. So we can plug this straight in here, and it will still move and transform our shot. We won't get the perspective data. In order to get the perspective data, we'd need to actually link this up to a corner pin. And we can do that easier inside the new Nuke 4, the new Nuke 7 tracker. So I'm going to delete that one, and I'm going to load up the new Nuke tracker. So if we look at the new Nuke tracker, it's got a much bigger panel where we can just add as many tracks as we need. And in this case, we need 4. And this is probably the only slow part of the operation, and we hope to improve this in the next version. But what we need to do is actually copy either the data from our corner pin to the tracks, or we can right-click the tracks and we can import the ASCII that we saved out. So if we go to a file and I go to my cube, we've got these 4 tracker node text files, and this is the sort of base format that works across almost all Nuke versions. So I'm going to load tracker 1 and bring that in, and you'll see that jump to the first position. So I'm just going to load the first 2. And I'll just change that number. And now if we select both, you can see 2. So this is really useful if you want to line up your surface corners. If I just switch back to Mocha for a sec. If you've got something specific you want to track to one particular corner, you can just load that one tracker area, and that will be a complete transform that you can use just off that one corner. So it's quite flexible in being able to load individual corners with that ASCII file, or you can also copy the corner pin instead. So here we can come up to our corner pin that we've pasted, and we can just right-click the animation menu over here and just copy animation, and then we can just paste that the same way. So we can paste absolute values, copy animation, and paste. So once we have all those, and I'll select them, and I'll just close my corner pin, we can still do the same methods that we can do in the old tracker node. So we've got the transform ability to stabilize. There's a few new features in here for different types of jitter and stabilize, like averaging out to a single point stabilize. But in this case, the other great feature inside the tracker node is being able to set a particular reference frame and then being able to convert to a particular node inside Nuke. So it means you can bring your data in to begin with in Mocha, but then do a lot of different transformations inside Nuke using just the one node. So in this case, if I wanted to convert it to using transform on a reference frame, I can create that node, and then I can plug that in, and it will transform according to that particular reference frame. In this case, the reference frame was set to 1. So it's going to scale it up to 1. So if I go back to, say, frame 99, and I set that to this frame, and I'm just going to delete that corner pin, and then we go back and create that again, it will now set it to this frame and then scale backwards. So you've got different methods of transforming that data inside Nuke. So there's another way to do this which is nice if you're doing full paints, and it's easier actually to do this inside Mocha. So I'm just going to delete those trackers and corner pins. And I'm also going to delete this Mocha because I'm going to bring in a different file. So I'm just going to read that, and I'm going to bring in my insert. And we'll go to the last frame. So I'm just going to do a pre-mult on this particular one, because I'm going to add a node to this one. And we'll merge that in. So I've just done a very quick and dirty paint on this final frame just to paint over the sign. So you can see that just sitting there floating in space. But this is a full frame paint, so it's the full dimensions of the footage painted into one particular frame. Now at the moment, if I just pasted the standard data, let's go back to my data and just export that tracking data again. And we paste that to this frame, you're going to see it just jump off into a tiny little corner, because we're dealing with a particular tiny bit of space and it's compressing that large frame down into one little area. So what we need to do in Mocha instead is use the Align Surface key. So up here we've got a button right next to the trash button called Push Surfaces to the Corner of the Image. And if we click on that, it will actually blow it up to the full frame, and then everything becomes relative to that point. So this is really good when you're doing matte paint replacements inside shots. So I'm going to put it right to the end and do the same. I'm just going to make that to the four corners. And then we can export that tracking data in the same way. So I'm going to copy the clipboard, go back to Nuke, and we'll just get rid of this one. And we'll paste that one back in. So now when we actually paste it back, you'll see it actually transform correctly because we've got that full frame. And I'll just double click on the corner pin so you can see that. So you've got this full frame of these four corners going right to that end and then scaling back. So that's the basics of the technicals of the tracking data. And now I'm just going to do a little bit more of a practical example. So I'm just going to close this one up. And we'll load up a new one. Nope. Okay, so let's go back to Mocha Pro, and I'm going to load up a simple track. So let's go to...
So Martin, while we wait, we have a question about the correct workflow. So the correct workflow is to crop in on the destination sign that you just did and reformat so that the sign is the same size as the comp, and then apply the Mocha corner pin?
Yeah, so you can do it two different ways. You can either choose, in this particular instance, we've got a surface corner pin set on his back here. So you can either crop it into the surface this way with these blue corners to set up a very specific insert, or if you're doing a full frame matte paint, which has actually got the full dimensions of the thing, so you're doing like a much larger scene replacement and you're actually doing full paints in the shot, you can expand out the Align Surface tool using here, and that will expand it out to full frame, and then you'll get the relative change when you paste it in to Nuke. So I'm just going to undo that one. So in this particular shot, I've just tracked the guy's back. Now, at the moment, you can see it's looking a bit like he's hanging a sign on his back, and it's not sort of flat and cardboardy. This is because, you know, backs, even though they're pretty flat, are not planar. So I'm going to bring this shot into Mocha, into Nuke, and do a little bit of warping to get it looking a bit more natural. So now we can do this one of two ways. We can either export out the data like we did for the previous, or we can also choose to render using the Insert tool. The Insert tool's nice and powerful in the way that you can actually physically warp stuff around, and it's also got the ability to do a much more in-depth warp right on the planar tracking data. So we can warp this around, and then that will actually warp with the planar tracking data without any additional keyframes. So it's nice and powerful what you can do with this. You can set your motion blur and your focal blur and then render that out to file, and then that will come across as a layer with an alpha that you can merge into your shots. So I've already rendered out an example of that, but I'll just go to a blurry frame so we can actually see that in action. So if I just render this particular frame, you can see how that blurs a little bit, and we can render the warp as well, but I haven't done a warp in this particular instance. I'm just going to now render that out full. So I'm just going to go back and render. So once we've rendered this, we can bring it out over to Nuke. First of all, I'm going to show you the data way, and then I'm going to show you the insert way, and both are reasonably quick. So once I've rendered that, we can see our...
But this is using Mocha's tracking... I was going to say, but this is using Mocha's tracking data in order to calculate the motion blur, right?
That's correct, yeah. So you're getting a nice, accurate motion blur by using the planar tracking data. So you don't have to add the extra node inside Nuke and have more overhead. So it is comping it into the shot, and you can adjust that motion blur however you like, but it's getting it from that motion inside the planar tracker.
I see.
So once we've got that file, I'm going to first export out the tracking data. So let's just copy that Nuke corner pin to the clipboard, and we'll come back over to Nuke. So here's the final shot that I'm going to go for, but I'm just going to move that over to the side for now. And we'll start a new comp. So I want to show you the complete process of how this works. So I'm going to load in my shot. So there's our shot there. And the first thing we want to do is, again, bring in that logo. So I'm just going to bring in the logo again. Let's get my insert. And we'll paste in our corner pin data. So that's our corner pin data there. And so the first thing we'll do is just merge that over the top so we can get that part going. So I'm going to select my corner pin data, select that one, let's just multiply our shot, and then press merge to merge that over. Like so. So we're still getting that cardboardy look at the moment. So we're going to do a couple of overlay techniques and some distortion to get this going. So the first thing we want to do is actually give this data version some motion blur. So I'm going to add a motion blur node. And so that will add just a little bit of motion blur. We can adjust that, but I'm going to keep it at the default settings for now. And we're going to add a reformat node. The reason we add a reformat node is because when you do a motion blur, it actually makes our box a little bit bigger. We want to reformat it back to the 1280 by 720. So I'm just going to press tab and do a reformat. And I'm going to tell it to format to none, and I don't want it to center either. So it's just pulling it back into 1280 by 720, which is what our footage is, and we get that box back into place. So now we're dealing with the same size again. So the next thing we want to do is we've still, even though we've got motion blur in here and we've got it tracking, we still don't have, it's looking still like he's wearing a cardboard sign. So we want to get that looking a bit more distorty. So for that, I'm going to use the iDistort node. So I'm going to press tab again and bring up iDistort. And iDistort's a really cool tool. The only thing I don't like about iDistort is I wish it actually had two inputs, the data that I'm using for the distort and the thing I want to distort with. Because it only has one input, we actually have to give it a shuffle copy to help bring out that data. So the way we do that is we select our footage, and I'm going to press tab again and bring up the shuffle copy. And this brings up a little sort of Rubik's Cube up in the corner here. So I'm going to shuffle copy that here. Now the way shuffle copy works is that it feeds the one value, in this case our footage, and it tells it to take whatever you've got here in the channels, in this case RGBA, and feed it into whatever you put into 2. In this case, I'm going to use the insert. And what you're telling it to feed in is a new channel. So in this example, say, for example, I had an alpha in my first channel. I could feed that into the second RGBA as its alpha. In this case, though, what I want to do is feed my RGBA values from my footage, in this case the back of the guy here, and I want it to convert into motion data in the insert. Now, the reason I want to do it in the insert is that I want to feed my insert into the distortion node, and the distortion node takes UV data, so UV channels, and I want to use motion. So the only way that we can get that data in is giving this insert another channel, and we do that with the shuffle copy. So I'm going to feed the shuffle copy into the reformat node here. And then once we've shuffle copied that in, and I've got it feed it into the motion, so I'm going to feed it over here to motion. So now when I look at this file, we can come up to our channels and we'll actually have motion data in there, which isn't coming up. Let's just check why I fed it into the right one. Okay, so I'm going to feed that straight into the iDistort now. So once we've got the iDistort in place, and I'm just going to press 1 to bring that up, we've got our iDistort up here, and we've got the channels. So in the channels, I'm just going to define it as all, and I want to tell it to use the motion from that file. Now, at the moment, you can't see it doing anything because we haven't actually adjusted our scale. So I'm just going to scale that up, and you can start to see it happening. It's quite small in here, so I'm just going to zoom in a little bit. You can start to see some distortion happening in here. It's quite subtle, if we can make it quite extreme. But this is getting the motion data converted from these ripples in his shirt now, because we've taken that RGB data from this shirt and we've converted it to that motion channel. So once we've got that motion channel, I'm just going to bring that down because that scale is quite large. So now what we can do is actually merge that on top of our footage again. So I'm going to take this down here so we can see this here, and I'm going to pull this up here just to make it a little bit cleaner. And we're going to take our iDistort data and we're going to merge it over our footage. So now we've got it distorting in the shot, but it's still sort of not looking right because we need to do an overlay. So I'm going to set my merge, and up here in the operations, we're going to go to overlay. So it's overlaying the entire shot. So the final thing that we need to do is make a mask for that distortion. So I'm going to actually do that from the distortion. So we've got our original distortion here, and I'm just going to grab the alpha from this distortion and make that a mask inside the merge node. So let's just take that off. And so to do that, we just make a copy. So I'm just going to tab and do a copy. And then once we have our copy, I'm going to feed the copy just straight into A, and copy, what it does is it copies just the alpha channel out of that, and then we can immediately feed that alpha into our mask of the merge. So when we press 1 again, we can see that coming up. So if I just disable that mask, you can see it's masking out the additional information outside of that merge, and then clumping in correctly. So now if we scrub through the shot, you can see how that's distorting and doing motion blur on top of our original tracking data. So when you're dealing with tracking data, you'd have to handle your insert, your corner pin, your motion blur, and your reformat But what you can do instead is actually just render that out in Mocha and get rid of all these. So I'm just going to disconnect those. And I've got my render here. And I'm just going to plug that straight back into my shuffle copy. And then that's done. So rendering in Mocha is a little bit easier because you can just combine all of that rendering into one shot, and you don't have to do all the additional nodes. The only downside to rendering is setting it up in Mocha to begin with to actually render it out, but also you don't have the flexibility of changing all of these values here. You would have to do it back in Mocha. But it's just a little bit quicker to have a single pre-comp thing, and it's also just a little bit faster, like we're not having to wait for additional render speed inside the viewer. Okay, so I'm going to move on now to Roto and some camera solving.
All right. So what you're saying is that rendering a pass gives you less control, but is faster. However, you can do the same exact thing using nodes inside of Nuke, and get the same result. It just takes a little longer to set it up in Nuke. All right.
That's right. You've got a bit of a flexibility ability inside Nuke. I mean, the great thing about Nuke is its non-destructive workflow. So if I want to sort of adjust my motion blur right in the app, we can do it right here, but we've got to wait for that motion blur to happen, and we've got to do the reformat node as well and all that kind of fun stuff. So if we do it back in Nuke, we can still do all that. We can set up our motion blur, we can set up our mats, we can warp it a little bit more directly in the insert comp in real time and do it with the planar. So you've got a trade-off between what you've got, but the great thing is that you can play with those. You can do some straight in the in Mocha and then do some more applications inside Nuke. So there's a nice balance between the two.
All right, thank you.
So I'm going to now load up a much more complicated thing. Let's pull up our... it's hiding on me. There it is. I have it selected and didn't even know. So I'm going to not save that one. Okay, so in this particular shot, so this is the same shot as before, but we've gotten rid of that logo. In this particular shot, we instead want to replace the background because it's been overblown. So we want to put some detailed sky back in this shot. So there's a few things that we need to do here. We need to rotate this guy, which I've already done, and I'm going to go through some basic techniques of how to do that. And we also need to track the background. Now, the problem with tracking the background is that we don't really have a lot of information to work with. We don't have a specific set of texture detail to work with. We could try and work with the corners of the buildings here to build up a corner pin. But again, we don't really have a lot to work with. We've got maybe one feature point here and over here. So what we want to do instead is actually do a 3D camera solve and then use a card to do the replacement back here. So I'm going to cover all of that in this one particular shot. So we'll start with the Roto, and I'll go through a few things in that. So I'm just going to minimize this and turn off my Roto for a second. And I'm going to start just by showing you a few little tracking techniques and Roto. So let's just zoom into the guy's head here. Now, generally the best way to do tracking for Roto is one of two ways. You can either track an object. So we'll start with his head. So you can track this object roughly, which is what I've done here. And then you can refine the shape. So you can go in and add more points and start manipulating to fit the shape of his head. Or you can just track once and then link Roto to that track. Now in this particular instance I've just tracked and then refined, but if you're working on a shot where you've got lots of little things, say for example I tracked this wall and I wanted to Roto the vent and I wanted to Roto the graffiti and a few bricks and things like that, I would want to track once and then link all my Roto to that shape, and we can do that via the linked track, which I'll show in a minute. Now I'm not going to go completely through the entire Roto because again that would be like watching paint dry, but we're going to just go a quick example here so that you can get the general idea, and then I'll show you the final stuff. So we'll start from here, and again I've just gone outside the edge because again we want to tell Mocha that the thing that we're tracking is actually moving on a background. So we want to give it a little bit of leeway. You don't have to do this. It just helps to, if you've lost detail within the shape, it's got some kind of edge to work with when it's tracking. So I'm not going to bother with perspective in this particular track because he's not moving that much in perspective. His head's sort of warping a little bit to side as he warps the cloth, so shear will do in this instance. If I was doing a full-on tracking data, actually using tracking data to insert something on him, I might be a bit more picky with perspective data, but because I'm doing Roto, I'm not that fussy about how the track turns out. I still want it to be reasonably accurate, but overall I'm just using, in this case, getting the tracking data to assist my Roto, not finish it off. So I'm going to start with that, and I'm going to start tracking this forwards. So we'll get the overall tracking shape. And you can see right now, because his head is not planar, I'd be a bit worried if his head was completely flat, you can see that it's tilting and warping, and we're not getting quite an exact track. And this is what we expect. Organic shapes are never completely planar, but it gives us enough motion to work with when we start to track. So I'm not going to track all of that. I'm just going to go back and start refining. So we've got, again, two options, as I said. We can either use our add point spline and start refining this shape. And you can add as many points as you like as you go, and it will still add to the original planar tracking data. With X-splines, which is what I'm using here, we can just right-click and smooth all our points at once. I find X-splines particularly good for Roto, and they work very, very well with our planar tracking data. A lot of people would be used to the pen tool Bezier, and you can still use that as well, and it still works very, very well, but I just prefer the X-splines. One thing you will want to know about X-splines, however, is that Nuke currently doesn't natively support them. So they will convert to Bezier splines when you bring them into Nuke. So that may make your decision easier, but generally I find Roto much, much faster when I'm working with X-splines. So here I'm just quickly refining the mat, and I'm adding a few more points here and there, so you can tweak and refine at the same time. If you're sort of starting to get a lot of points and you're not really sure and you can't see well where the mat is, the splines are going to be high, on the edge here, we can actually hide the splines and just work with the mat. So I'm going to turn on the mat here. And over in these view tools, we can actually set it to turn off the splines completely. And we can also tell it to just look at selected tangents. So it really reduces the amount of stuff we have to see in the scene so we can more accurately look at what we're trying to roto here. And you can also see up in this window we've got the pinpoint, so you can actually see how well that's going. If I move forwards, we'll get the previous and current keyframe, so you can actually see how that is going for the next frame. And obviously if I move my mouse over, it will get out of my way if my roto is over here. So I'm not going to refine more of that. I just want to show you the other technique now. So I'm just going to hide this layer, and we'll call this one track. Head track. Always good to name your layers accurately. And I'm going to turn off the tracking data and just hide that for now. So the other method you would use is to do a very refined mat to begin with, and I'm just going to turn my splines back on. So I'm going to do quite a detailed... Now I should have switched back to my Wacom pen before doing this because it would be much quicker. Just like so. And again, I'm being a little bit rough, but you get the idea. And then what we can do is just take this layer, and I'll call this one Head Roto. So we've got this thing down here called Link to Track. So we take our Head Roto, and we just say, link it to the head track. And now that will move along with the tracking data that we've got in the other scene. Now, again, it's not going to be perfect because we've not tracked completely, but it gives you a starting point to work from. So now, if I wanted to roto something else down here, I could also link it to that head roto, head track, and keep on building up some roto for the base of his neck here. I would probably, as I got further down, though, would actually track a different section because his head's obviously separate from his torso, his arms are separate as well. So looking at the arms, for example, if we just zoom back out, The arms, we've got a nice big swing in them, so we'd probably want to track perspective in this instance because the tracking is moving back and forth in the shot, and then you can again refine your roto around that perspective track. So I'm not going to do that now. I'm just going to trash this one, and I'm going to trash my head track, and we'll look at that final result. So I'll turn on my mats, all mats. So I have rotated this arm, but I don't need it for this shot, so because I'm only caring about the background here. So we've got that fully rotated now. And if we take a look at our head, for example, we've got a fair amount of keys in here, but the overall motion of the track is what's helping our roto to begin with. So once we've got this, we can now export it out to Nuke, but first of all, I'm going to do my camera solve behind this. So I'm just going to minimize that for a second. And we've got these 3D solver tracks down here. So the way you do 3D camera solving inside, I'm going to turn off my roto for the man. The way you do 3D camera solving inside Mocha is by tracking planes and then giving Mocha some depth to work with. So in a moving camera shot, like this one, we need at least 2 non-coplanar planes. Now what I mean by that is I can't just track this wall and then track over here and expect to get a good moving camera, because Mocha needs some depth to work with to actually define what the camera is doing. So in this instance, this wall over here is on a different plane to this wall. They may be parallel, but they're on different planes. So I've just tracked this wall, and we can see that if we scrub through. Now you can see here how this guy is actually passing over the right wall here. If I turn on my track mats up here in the mat drop-down, and I select my left wall track, did I turn on track mats? I just select track mats, yep.
Martin, I want to give you a 30-minute warning. We have about 31 minutes left.
Okay, great. We're almost done here. So if I just turn back on my track mats, we can see how that roto is now cutting him out. So that's just a way we use to use foreground elements to help stop tracking data from being obstructed by foreground elements. So once we've tracked 2 non-coplanar elements for moving cameras, we can just select those 2 and then go over to our camera solver. Now we have auto functions here, and I'm not going to go into massive detail here. We've got some great tutorials on using the camera solver specifically for Nuke. And we've got an auto camera which guesses the best camera to use. In this case, I know it's a large parallax change because there's a lot of motion going from foreground to background. I know it was a 35 to 70mm lens, so I'm going to keep that focal length, and I know it was zooming. So we can just go ahead and solve that. So this wall's now solved for the selected layers, the 2 walls, and it will turn away up here in the corner and let you know when it's done. This is a reasonably short shot, so it won't take that long to solve, and we'll get a pretty good result out of this one. If I remember correctly, it was about 94%. Okay, so that's come out at 94%, and then we can export out that camera data. So we can export out to FBX 3D data for Nuke, and I just want to quickly point out why it's 6.3 v7. The reason we export out to this particular Nuke version, this is for this Nuke version and above, is because below this version the points in the FBX do not show up correctly inside Nuke. FBX wasn't fully supported until this version. So then we can save that out. I'm not going to save it out right now because I've already saved it and we can load it into the other shot. So let's go over to Nuke now and do that. So we're going to close this one up.
They're preloaded for your convenience.
That's right. I want my own baking show so I can actually say, here's one we baked earlier. Let's bring up this one. Okay, so here's the completed shot. So I'm not going to go into great detail with how all this works, but I'm going to show you how to very quickly set all of this up. So I'm going to just start by deleting all this. and we'll start again. So I'm going to load in that footage. So we've got our footage there. Now the first thing for doing a 3D card is we need a scene. So I'm going to set up a scene node. And then I'm going to need a camera. So I'm going to bring in my camera. And we need to render out the scene, so we're going to use a scanline renderer. So the scene links to the scanline renderer, and the camera links to the scanline renderer. And we also have this background, which links up to our footage. So we'll put that over there, and then we'll put that down there. So you still won't see anything yet because we don't have any data in these. Now feeding into the scene, we need a read geo to read in that FBX data. So I'm going to pop that in and feed that into the scene. So this will set up our basic 3D scene. I'm going to load my camera first by double-clicking, go to File, Read from File, and load the FBX. So we'll load up our FBX file, which is just here. It asks us if we want to destroy, which we do. And then we load in our read geo. So we do exactly the same process. We read the file, and we'll go to follow up, and we'll lead in that FBX. Now you still won't see anything just yet because we're dealing with mesh data here, and what the FBX has brought in is a point cloud. So I'm going to click on point cloud, and now you'll see those points come up. So you can see the individual points here, and these actually represent the 4 corners of the mocha project. So if we go back to left wall and we turn on our surface, you can see the 4 corners there, and the right wall, the 4 corners there. And it also derives a middle point just so that you've got a bit more cloud data to work with. So once we've got this information, I'm just going to press tab so you can see that in 3D. So that builds out a really nice set of wall nulls, and then we can use those to help position our card within 3D space. So that's what we need next. We need a card. So I'm going to just drag down here and press tab and do a card. Now we could do this with a card 3D as well, but I'm specifically doing it with a scene and a card because it gives you a little bit more flexibility in 3D. So I'm just going to press return on the card, plug that into my scene. Now it's very, very small at the moment, so I'm going to make that a lot bigger. So we'll make this about 1500 in X and about 3000 in Y. There we go. Whee! And then I'm just going to move that back in space a little bit until we're actually past our nulls here, just like so. So now if we press tab again and go back to the window, you can see we can't see anything, so it's not far enough away yet. So I'm just going to push that back in Z space a little bit, so we'll just pull away. It's going to pull that back a little bit until it covers that area nicely. Let's have a look and scan through our shot. So that's covering it pretty well. Yeah, I'm happy with that. So the next thing we want to do is, obviously, it's covering most of our shot. So I want to bring my Roto in. So I'm going to go back over to Mocha. I'm going to go back over to the track node and select my man here. Now I'm only just selecting one part of the shape because I'm only going to export the visible data, and in this case the visible data is just my man. I've turned off the eye for my 3D solver tracks. So I'm going to export that shape data out, copy it to the clipboard, and then we can, oops, sorry, I did that wrong. I've got to export all visible layers, and that will export out all of the ones that have eyes on them. Now, before I go from here, again, we need to point out the versioning. The reason that it's Nuke 6.2 Roto is that from 6.2 onwards, Nuke started supporting our perspective data. So when you export out the Roto node specifically, you're getting transform data from the tracking, and you're getting the manual keys that you've set from the spline. So this means when you bring it into Nuke, it's a lot easier to manipulate your Roto when you get it into Nuke, because you've still got a free-form amount of manual keys and not a keyframe on every frame like in previous versions. That's not the case for Nuke Roto Paint. Nuke Roto Paint still has a keyframe on every frame, so be aware of that. Nuke Roto Paint will be a little bit more data heavy than the Nuke 6.2 Roto. So I'm going to copy that to the clipboard. and we'll go over back to Nuke. And again, we're just going to do a merge over. So I'm going to grab the original footage. I'm going to paste my Roto into there, and we can see that starting to come up there. It's that nice virulent green. So I'm going to double-click on that, and I'm going to output as alpha, and I'm going to pre-multiply the RGBA. So at the moment, it's still behind the card, so I'm going to put my background back into the scanline renderer, and then I'm going to merge over the top. So I'm going to merge that Roto over my scanline renderer. So right now it's going to have a little bit of a nasty edge, so what we need to do is actually pre-multiply that Roto. So I'm just going to press tab and do a pre-mult, and that will just clean up that edge a little bit and make it nicer. Whenever you're doing a merge in, it's good to do a pre-mult just so it cleans up the alpha on the edges. So now we've got our Roto in front of our card. We can then bring in the walls, because the walls also have to be covered in that thing so that we're only cutting out that space. So I'm not going to put that in now, but I'm going to show you what I did for that final thing. So I'm going to reopen the original file. So I'm just going to close that and say no. And that closed the whole thing, so let's go back to Nuke. And we'll just open that file and I'll show you what I did there. So we'll load up the final thing. I'm going to say no. So here's the final result. I'm just going to turn this one off for the time being because we didn't do that part yet. So I've just brought in the wall here. This wall here is the same Roto as before. And we've just multiplied that over the top. So a similar Roto to the man, but we've just cut it out so that only the space up here is covered by the 3D card. I then just brought an image in there into the 3D card. So if I just go to my card view and we zoom out, we can see that card in space. So I've just got a nice detailed cloudy day in San Francisco there. And I'm just going to, and I've just cropped it down with a rectangle tool. So originally, if I disabled that, it was a much larger image, but we've just cropped that down. And we've done a little bit of color correction just to make it look prettier in the scene. So that combines it all together. So we've got the motion of that 3D card, and I'll close my Roto so we can see that a bit better, and we'll fill the screen. And we've got the Roto of the guy over the top. And we've got the Roto of the walls as well. Now, in order to refine the edges of this a little bit better, we can either choose to render out our mattes inside Mocha Pro and choose to turn on the motion blur. If we render the motion blur out, we actually get a much nicer... so we go to the matte for the head here. I'll turn on mattes. We see we get a motion blur render from that. So when we render out a full set of mattes from that, you'll actually get all the motion blur for free inside the shape renders. You won't get that with the Roto data specifically unless you actually apply motion data nodes like we talked about with the tracking data. Alternatively, you can also bring in your own feathering. So if I was to feather out this particular matte node, just select that in here. No, my computer's slowing down. Why? Always when you're doing a demo.
Well, that's the law of demos. So, of course, it's going to slow down. You've also opened like 10 files in a row.
That's true. But we have closed them. So hopefully it will actually be nice again. So yeah, we can pull off that here. So if I just zoom in a little bit. Nope, it's really going to slow down for some reason. I'm guessing it's my computer's breathing very heavily here in the studio. So something is taking up my memory.
Well,
so anyway,
it's a laptop.
The mattes will render out. So yeah, basically what will happen is the mattes will render out with that motion blur and you'll get those soft edges without having to do the feather yourself. So finally, before we wrap up, I'm going to show you how to use the lens tool. So I'm just going to close that up. How are we going for time, Mary? Have we got another...
We have 20 minutes left.
Okay, perfect. I can do lens in about 5 minutes, and then we
Wonderful.
can open up some more questions. So let's pull up a new. I'm going to say, don't save on this one. Okay, so in the shot, this is shot with a 35mm lens, and even though it's subtle, there is some lens distortion in this shot that we want to get rid of. So to do that, we can just use the lens module and then bring out a distortion map into Nuke. So over in lens, we can either locate the lines in the original scene, which will just put up a whole bunch of these lines, and then we can detect which ones are straight and help line them up. But in this case, because there's a lot of sort of not very continuous lines in here, I'm actually going to bring in my own calibration clip. So I'm going to come down to my calibration clip and do import, choose, and we'll come to our sky and bring in our calibration grid, and I'll just import that. So we can still see our lines in the background here, but this is our grid that we've shot just straight on a monitor, but this actually works really well. You can just do a straight shoot straight on the monitor. So I'm going to locate the lines in this calibration grid, and I'm just going to use the edges of the grid in this case because I don't have a lot of warp in this grid. So I'm going to just start a new line by pressing new line, and I'm going to tell Mocha these are the lines that I think should be straight. So I'm getting the very edges of this screen here, and I'm just going to create a new line every time I'm going to a new section. And that's probably due. I've just connected these two lines up here. I've connected these two lines down the side, and I've defined this line, and that'll be enough for Mocha to get a calibration in this instance. So in the calibration section, we've got distortion, and we can set up particular distortions here. Now, I know this is a one-parameter distortion. What one-parameter distortion means is a barrel distortion. So there's a distortion from the middle of the lens going outwards. A two-parameter distortion is where you've got a wave in your lens. This is actually quite common with fisheye lenses, especially with the great sports cameras like GoPro and stuff like that. They're really, really good fisheyes, but you can sometimes get that tiny little bit of a warp at the edges of the lens, and so this helps fix that. We've then got an inverse distortion, and we've got some anamorphic as well. And I won't cover bringing distortion maps in today.
But you
so
can.
I'm going to choose a.
But you can bring distortion.
You can bring it straight in from Nuke. You can bring it in from Nuke. You can bring it in from Maya or something like Buju to actually use a UV map to do the distortion.
Well, can't you also render one out of Mocha and then bring it in as well for other shots that you don't have grids for?
Absolutely, and that also means that you don't have to recalibrate like I'm doing here. Like, if you don't want to go through the tedious process every time of actually doing a calibration grid, it's a great way to save out your lens data. So you can just save out your own distortion map and then bring that back in to do other shots.
All right, perfect.
So I'm going to calibrate this now. And we can see this just subtly warped. You can see that green line now is warping and around here as well. So I'm just going to go back to my original shot. And I'm going to turn on the grid, and we can see how that grid is warping slightly. So I'm going to move to another section over here. And we can either choose to render this ourselves inside Mocha, so I can click that and it will render it flat, and we can see the difference if I turn off the grid. So we've got a very subtle warp, but the warp is definitely there. You can see it mainly around the edges. And we can do it this way, and we can get a static file, and that's actually quite useful if you're not planning to keep the distortion in the shot. But if you want to do a non-destructive method, you can instead render the lens data. So I'm going to export the lens data now, and I'm going to choose distortion map clip, but you can also export out to our plugin for After Effects. And in this case, you can see that the dimensions are slightly weird. That's because it's trying to calibrate the best size for the distortion map. So this is a 1280 by 720 clip, just because my laptop's a little bit slow. And I've got my distortion map clip a little bit larger because it's trying to accommodate for that size and warp of the lens. So I've already rendered this out, so I'm not going to bother. You only need to render out one unless you've actually got an animated lens warp, which doesn't happen very often. So I'm going to just cancel that, and I'm going to load the distortion map I've already saved into Nuke. So here we are over in Nuke, and we'll just load up the file. So I'm going to bring up that pan up sky. So there's our shot. Let's bring it in, and we'll make that a little bit bigger so we can see it. And so first of all we need to do is bring in our ST map. So I'm just going to press tab and do ST map. And initially that won't do anything because we haven't done anything to it. So what we want to do is bring in our ST map. So I'm going to press R to read in that. And we've got our understored clip here. So I'm going to open that up. And we get this beautiful color, like hypercolor 80s UV map. And we just feed that straight into the ST map section of the node. So now when we look at the sort of hypercolor. So once we've got ST map, we need to feed our channels in. So my channels are RGB, and I want the UV channels to be RGB. So now when we look at our shot and I press, if I disable this ST map, you can see that warp happening in the shot. Now the downside to the ST map is a bit like the motion blur node. It actually makes your footage the size of the distortion, which is not what we really want. So we need to do a reformat on that. Like so. And I'm going to reformat that to the original footage. And I want to set that to none, and I want to keep it centered. So now when we disable, we can see how that comes in and out of our shot. So finally, what I want to do is to show you how to deal with tracking data now we've undistorted a shot. So I'm going to go back to Pro, and I'm going to load up an existing shot. The same shot, but just with some tracking data in it. So this is exactly the same shot, but I've just tracked in some data here. So I've just tracked this window, and I've added another window down here. So we can see this window if I turn it off, change it to a logo. So we just added another window. So I'm going to export out this tracking data, but there's a very important thing you need to do when exporting out to undistorted shots. So I'm going to export out the tracking data to Nuke corner pin, but we need to check this box before we export it out, because if you undistorted your clip, it won't line up correctly because it's going to assume that you're using the original data. So I'm going to remove my lens distortion, copy it to the clipboard, and move back over to Nuke. So I'll bring that window in. Got the window. We will merge the window over the reformat. So we can see it's nice and big at the moment, and then I'm just going to paste that corner pin data in. So now you can see it down here. If we just zoom in a little bit, we can see that tracking in with the correct lens distortion position. If I didn't bring that distortion position in and I just exported it as normal, what you would get instead, and I'll just disable this one, is a completely offset file because it's assuming that we're not using lens distortion. So if you've flattened something out, you can use the unremoved lens distortion, but if you've undistorted the lens, you want to make sure you check that box to get the right distortion into the shot. So that pretty much wraps up what we wanted to talk about today. I'm just going to go back to the keynote.
Well, we're going to open it up to questions as well for the next 10 minutes.
Yeah, sure.
So, exactly. So we're going to be at SIGGRAPH in Anaheim for 2013. That's going to be July 23rd through the 25th. So please come visit us at booth number 744. We also have, if you go to www.imagineersystems.com, we have a code you can use to get an exhibits only pass. You should definitely use that. I'm going to let Martin take the internet stuff.
Oh yeah, so this all is the places that we exist on the big wide world. So we're on our main site at imagineersystems.com. If you've got sort of detailed questions, you can post them to the forum and we'll help out. We're pretty quick at getting to them every day, but also community members help out. And we've also got our Vimeo channel, our YouTube channel. They've got all the tutorials synced up on both sessions, but we also share customer footage. So if you've got some great examples that you've done inside Mocha, definitely send them along to us because we like to share them around, especially if you've got your own YouTube channel or Vimeo channel. We love to share what people are doing with Mocha. We've got the Facebook page. It's good to go and like the Facebook page because occasionally we give out free stuff for likes because we like to do that. And we've also got the great Imagineer Systems Twitter account where we post out Mocha tips almost every single day. We take weekends off because I get sleepy. So we've got all of these places to go. Definitely give us an email if you want to know more. We can go to support@imagineersystems.com. Feel free to also email me directly if you've got other questions specifically about what we talked about today, which is martinb@imagineersystems. And I will open up to any other questions people have.
All right, so we've got 8 minutes left, so does anybody have any questions they want to ask Martin? We will go over specifics.
Type away.
Yeah, I'm seeing all kinds of typing, but mostly it's that everybody loves the webinars, which is wonderful. We love to hear feedback. So, as I said before, on your way out in the next 10 minutes or so, when you guys bug out of the webinar, please leave us feedback. It's how we know what to do for the next webinar. We've done these every month for the last 5 months, so we want to continue to do them.
And also, if there's any Nuke pros out there, we'd love to hear from you too, because we're always interested in hearing great new techniques to apply data within other applications. Like, we know Mocha fantastically, and we know other applications, how they work with Mocha. A lot of us have come from different backgrounds, but we love to hear from experts on getting new tips on how they're working with these kind of workflows.
Exactly. And we're always looking for more demos as well. So if people are doing demos, or if people are doing cool stuff with Mocha, we want to see it.
And footage, we love footage, because then we can put it on our reel and plug you and plug Mocha, and it's awesome.
All right, and the feedback form is on sign out, guys. So we have a question here. Is there any ST-map export option in Mocha? Yes, it's a renderable. In the
yes, that's right.
lens.
So I can just switch back to that quickly. So when you actually export out the lens data, here you export out specifically the distortion map clip. So we call it a distortion map clip just to be universal, because pretty much only Nuke, as far as I'm aware, uses the term ST-map inside compositing applications anyway. So we call it a distortion map clip because that's a more generic term for people who want to use it in, say, Fusion, or when Pixel Bender was in After Effects, which was sad to see that go, because that was a great distortion map clip. But that's why we wrote the plugin. So distortion map clips are ST maps, basically. So you just feed those into the nodes. We don't specifically export out the node itself, because the node requires that UV map as well.
Exactly, and we also had a question on whether or not we could get this lens data into After Effects, and we absolutely can. We can get it in as a lens tool, and also the distortion map can be read by some plugins inside of After Effects, but Martin's showing you the export right there.
So that's the Mocha Lens for After Effects. You do need to download the plugin. The plugin is free with Mocha version 3, so you can just download that, and it's part of the license, or it may even be unlicensed, I can't remember. But it's part of the Mocha Pro, but you can only export from Mocha for After Effects version 3 and Mocha Pro version 3 to the After Effects Lens plugin.
Also, Martin, we wanted to see, we have a user here who definitely wants to see how you import a lens grid to calculate the distortion map from.
Sure. I'll just repeat that right now. So, and again, there's 2 amazing tutorials up online that go into massive depth about this. So we did some very long ones, but it's just down here. So normally what you set up with in the beginning, your calibration clip and your input clip in the lens tool. So when you begin with the lens tool, they're both set to the same value, which is the clip that you import. Because when you actually locate lines on that clip, you can often get a really good lens calibration just straight off data, but often you need straight lines to get good information. So it's great for urban environments, but if you're right in the middle of a jungle, you're sort of screwed. So when if you've got the same lens and you're using it a lot, it's great to shoot it in an urban environment first, and actually you can just use any old footage that you've shot with that lens to calibrate the clip. But often it's nice to use that grid, because some lenses, especially specific professional lenses, have a very defined warp, and it's very easy to just load up that calibration clip. So here you just drop down, and there's a little import tab in the drop down. So we just click that, and then you can import whichever clip that you're using, so the calibration grid in this instance. So I've already done that, and we just select that, and then that'll come up and we can start locating the calibration.
All right, perfect. I'm still running through questions. Sorry, guys. We got slammed with them very quickly. We have a request for ion fusion webinars in the future, which I would love to do, but we'll have to see how much interest we get for that, and that would be definitely something we'd like to do. What's the function of the green lines pulled up in this shot here on the corrections? Okay, so the green lines, do you want to explain those, Martin?
Yeah, sure. So how the green lines work is this is telling us Mocha's just gone through and said, here are all the straight lines that I think should be straight. It's basically saying, I found a whole bunch of lines. What do you want me to do with them? So, and you can define that by the line length down here. So we've got minimum line length, so I could set this down to like 10, and then it will find a huge amount more. So now it's finding every little grid line in between these points. But if we don't want to find that many, we can say make it 40, and it would only find major lines. So once we've got those lines, we can then connect them up. So I'm going to set that back to 20, and I'll define a new line, and you just select. So what you want to do is, we'll try it with this one, middle one here for the beginning. So when you start a new line, you want to join up the lines that you think should be in a straight line. It's sort of telling Mocha, yes, you're correct, this is a straight line. And so once you've got a straight line, Mocha can go, okay, so if this line is supposed to be straight, I know how to distort the lens to make that straight. So you just define that, and it's best to do the edges on simple lenses like this. This lens has got a nice curve on it, so it's very easy to get the barrel distortion. But on those fisheye lenses, you may actually need to go through and define every line in one grid and every line down another grid so that you can discover that warp that's going on in the lens, because lenses have a lot of personality, like every single lens is different.
Exactly. We have a question about, can you track a moving object inside of a 3D track in Mocha? And the answer is yes, of course you can, but you have to solve for the camera first.
That's right. Yes, so the way you would do that, and we've got a couple of good tutorials on that in the webinar. If you go to the 3D Camera Solver webinar that we recorded recently, we go through that in a little bit of depth towards the end of that webinar. We track a cool visor thing to someone's face. So the way that works is that you still define the environment using static. So you still have to define the static variables because Mocha has to know the world that it's living in. And once you've defined that camera, you can just do a planar track on any moving object in that scene and immediately export that out as moving 3D data. So it's quite powerful in that respect.
We have somebody asking if it's possible to get a 2D scene of this. I'm not sure what they mean.
Oh, you mean you want the footage?
I don't know. Let's see. Okay, moving on. Let's see. Taking Roto Nuke. Oh, okay. So we have a question here about doubling up X-splines, the points that from X-splines to Nuke. That's just going to happen, and that's just because of the way they translate.
Yeah, unfortunately, the maths involved between X-splines and Bezier means that you cannot have the same amount of points. You would, because of the way the curves work with tangents in Beziers and the curves work in X-splines. X-splines are basically like B-splines with control points, so it's very, very hard to translate data between those. So ideally what we'd like to see is X-spline support inside Nuke. But for the time being, the only way around it is the additional points inside a Nuke with the Bezier spline. So that is a bit of a pain. But we think the overall speed of the tracking data and the way the X-splines work makes up for it, because you can easily go back and tweak easily inside Mocha and then re-export.
All right. Is it possible to track distortion? So yes, that's actually why you solve for the lens in the first place, is so that you can track through the distortion. So,
unless you're referring to distortion as in distortion, say for example on cloth, we still can track shear. We can track that distorting shear, but we wouldn't be able to track, say, someone crumpling up a piece of paper or something like that, because that's not planar anymore. We specifically deal with planar stuff, and it will just treat distortion in a plane quite well. It'll ignore stuff that it doesn't think is worth tracking, but you're not going to go ahead and track, say, like a turbulent ocean, for example. So if you mean that's the sort of distortion, there's sort of a yes and no answer to that.
Sure.
And you can accommodate for that. You can actually use the warp tool inside insert to actually accommodate for some of the distortion going on.
Also, sometimes, as long as the pixels are moving relative to one another, you can track mild water distortion, stuff like that, but it has to be moving relative to one another, not fractally. All right, guys, this is the last question we're going to take, and then we're going to close the webinar because we are out of time, but we really hope that you appreciated it. So we have a question: if you can use 2D, if you can use mocha to convert a 2D scene to stereoscopic 3D, yes, you can. You just need to do a lot of roto, but we cut roto time in half. So
you can bring that, but if you import the left eye as the hero eye, you can also then import the right eye in the clip tab, and you can also roto through that. We generally recommend sort of keeping stuff separate, but it's definitely possible. I mean, roto and stereo are probably one of the largest customer bases for mocha. Like, it's used in stereo houses all over the world to do both stereo conversion and just straight stereo. It's very, very powerful for that.
All right, and Mocha Pro works with all sorts of programs. So we don't just work with Nuke, we work with Fusion, we work with Final Cut, we work with After Effects, we even work with Quantel, so there's a lot of options you can do. We export our tracking data to Autodesk, Avid, Boris, Digital Fusion, Final Cut, Motion, Nuke, Quantel, and Shake. So if none of those formats work for you, please let us know. We export our shape data to Combustion, Flame, Nuke, Shake, After Effects, and Final Cut, and if none of those work for you, let us know. We can also render out our mats as black and white mats to work with custom software. Thank you guys so much for attending. I'm going to let Martin wrap this up.
So yeah, thanks guys for that. When on all else fails, you can do renders, so that's always a nice thing with any application you're using. Thanks for taking the time to watch this, and again, let us know if you've got any more questions, either via the forums or via support. Thanks very much.
All right, thanks so much. Bye.